We are now looking at the last part of section 7.2, and here we are going to look at what happens if we have integrals in which we have tangent and secant functions together with different powers. So the first example I'm looking at is when the power of secant is even. So note here, the power of secant is even and the power of tangent is odd. So note here. So in this case, so this is what is important, that the secant has a even power. So whenever you have this situation, what you are going to do is separate a secant square x and leave the other powers, whatever is left on the rest of the secant, and then convert this secant into tangent, powers of tangent, by using the Pythagorean identity. So remember this Pythagorean identity, that secant square x is tangent square x plus 1, or 1 plus tangent square x, however you want to remember. So now this is what we have. And why we do this? Because we remember that the derivative of tangent is secant square. So now we can use the substitution. Let u equals tangent x, then du will be equal to secant square x dx. So substitute, and it just becomes simple powers of u, and then we integrate, and then we go back and replace our u by tangent x, and then the final answer I have here. So the next example I took is when still the power on secant is even, but now we have even power on tangent as well. So it doesn't matter again whether the power on tangent is even or odd. The important thing is that the power on secant is even. Again, in this case, you will follow the same procedure. So separate one of the secant square and then convert the rest of the secants into tangents or powers of tangents by using the Pythagorean identity, and then use the substitution u is equal to tangent x, du will be secant square x dx, replace, and then eventually we end up as powers of tangent in our answer, and that's what the answer looks like in this case. Next example is different, because now here note that the power of secant is now odd. So it has changed now. The power of secant is odd, and the power of tangent is odd as well. So this is the difference. The power of secant and tangent are both odd. In such a case, we have to recall that the derivative of secant is secant into tangent. So we will take out one of the tangent from the whatever the power of tangent is. Because the power of tangent is odd, so when you separate one tangent, the rest of the power on tangent will be even. And we will do the same thing with the secant. We will take one secant separate, put one secant separate, and the rest of the secants will have the even power. Now we will convert, we will put the tangent x and the secant x together. That's what I did over here. And then the secant to the 4x, which we have in this case, I left it as it is, but the even power of tangent, we are going to change it to secant. So tangent square x is going to be written as secant square x minus 1. And in the same idea, that if it was tangent to the 4x, you will write it as secant square x minus 1 whole squared. Now this time the substitution will be u equals secant x. So the du is secant x tangent x times dx, and then just go back, plug in everything, and then we have powers of secant this time, and then final answer. So not too bad. But what happens if we have even odd power on secant, but now we have even power on tangent? So now we are in a little bit of trouble, because we cannot separate secant square x. If we do, then we are left with secant x, and secant x cannot be converted into tangent x. If we separate the just one secant x from here, we need one tangent x. So when we take one tangent x, now we are left with odd power on tangent, and we cannot convert that into secant. So this one is very different from the other three. So how to tackle this one? Well, it's not that easy. I mean, it will be long problem, but so you actually won't get these type of problems on the exam, but just wanted to show you that how we can do these type of integrals. So what we do here, we are keeping our secant, whatever the power on it is, as it is, and we are converting the tangent into secant. So all the tangent into secant, because tangent has an even power. So when we did that, so in distribute, and we end up getting integrals with powers, odd powers of secant. And how do we tackle that? In the previous video, I showed you how to integrate secant cube x, how to integrate secant 5x, and I asked you guys to try doing secant 7x. So that is how you will be solving these and getting the answers. So in summary, if we have this situation, that if we have tangent mx times secant nx, if n is even, which was the case in the first two examples I showed you up here, so if n is even, the power on secant is even, then we will keep 2 secant x, and convert all the rest of them into tangent x by using the Pythagorean identity, and then you will use the substitution u is equal to tangent x. Now if m is odd, okay, now m is odd, so m is odd means we can have actually we can have now secant even or odd, it doesn't matter. So if m is odd, you can actually do it this way. You can convert all but one tangent to secant, and then use the Pythagorean identity u is equal to secant x and solve it. But now this is the last case, that if m is even and n is odd, so m is even and n is odd, as in this example number 4, then you can try by integration by parts, as I just explained here. So this is how we integrate the trig functions.